According to the National Electrical Code, the best way to splice these cables is using crimp connectors. Solder splices are not allowed for outdoor applications as they can corrode over time, leading to a safety hazard. Crimp connectors provide a secure and permanent connection that can withstand the harsh outdoor environment. Use insulated crimp connectors specifically designed for splicing the combination of number 6 and number 10 gauge wires. These connectors are available from various manufacturers and have a wide range of options based on the number of connections and wire sizes. There are no wire nuts available that can accommodate a splice of 2 number 6 and 3 number 10 gauge wires. Wire nuts are typically limited to splicing wires of similar gauge and are not suitable for this combination. To complete the splicing procedure, firstly, strip the insulation from the number 6 and number 10 gauge wires according to the manufacturer's specifications for the crimp connector. Secondly, insert the wires into the appropriate crimp connector. Thirdly, use a crimping tool to apply even pressure around the connector, ensuring a secure connection. Fourthly, wrap the splice with electrical tape for additional protection. According to the pole manufacturer, each pole can accommodate up to 7 number 6 gauge cables. This means that each pole can have one number 6 gauge circuit with a maximum of 3 number 10 gauge wires connected to each fixture. Ensure that the conduit size is adequate for the number and size of cables it contains. Use antioxidant paste on all connections to prevent corrosion. Install a disconnect switch at the base of each pole for servicing and maintenance purposes. Follow all applicable NEC requirements and local building codes. When dealing with electrical installations, understanding and adhering to the National Electrical Code, or NEC, is paramount for safety and compliance. The NEC provides guidelines for safe electrical practices, and it's essential to consult the latest edition for specific requirements in your area. Let's delve into the specifics of splicing wires, particularly in the context of parking lot lighting poles. The NEC generally favors crimp connectors for outdoor applications due to their reliability and resistance to corrosion. Soldered connections, while sometimes used, are not recommended for outdoor use because they are susceptible to corrosion, which can lead to loose connections, overheating, and potential safety hazards. Crimp connectors, when properly installed, create a secure and permanent connection that can withstand environmental factors. Selecting the right crimp connectors is crucial. You'll need connectors specifically designed for splicing different gauge wires such as number 6 and number 10. These connectors are available in various configurations to accommodate different numbers of wires. Consult the manufacturer's specifications to ensure the connector is suitable for your specific wire combination. Wire nuts are a common method for splicing wires, but they are typically limited to wires of similar gauge. In your scenario, where you're splicing 2 number 6 and 3 number 10 gauge wires, wire nuts are not an appropriate solution. The NEC does not approve of them in this instance. Now let's outline the recommended splicing procedure. Firstly, prepare the wires by stripping the insulation. Use a wire stripper to remove the insulation from the number 6 and number 10 gauge wires, exposing the bare conductors. Follow the crimp connector manufacturer's instructions for the correct stripping length. Secondly, insert the wires into the crimp connector. Ensure that all the wires are fully inserted into the connector barrel and that they are properly positioned according to the manufacturer's guidelines. Thirdly, crimp the connector. Use a crimping tool specifically designed for the type and size of crimp connector you are using. Apply firm, even pressure to create a secure and reliable connection. Refer to the manufacturer's instructions for the correct crimping procedure and tool settings. Fourthly, protect the splice. After crimping, it's a good practice to wrap the splice with electrical tape to provide additional insulation and protection against moisture and corrosion. Use high-quality electrical tape that is rated for outdoor use. In your scenario, the lighting pole manufacturer states that each pole can accommodate up to 7 number 6 gauge cables. This information is helpful for determining the maximum number of circuits and conductors that can be safely installed within each pole. However, it's crucial to ensure that the conduit and wiring meet all applicable NEC requirements. Additional considerations for your parking lot lighting project include ensuring that the conduit size is adequate for the number and size of conductors it contains. The NEC specifies fill requirements for conduits, and it's essential to follow these guidelines to prevent overheating and damage to the conductors. It is also important to use antioxidant paste on all connections. Applying antioxidant paste to the bare conductors before splicing can help prevent corrosion, especially in outdoor environments. This paste creates a protective barrier that inhibits oxidation and ensures a long-lasting connection. Install a disconnect switch at the base of each pole. A disconnect switch allows you to safely de-energize the lighting circuit for maintenance and repairs. This feature is essential for worker safety and is often required by local codes. Ensure that the disconnect switch is properly rated for the voltage and current of the lighting circuit. Always follow all applicable NEC requirements and local building codes. Electrical installations must comply with the NEC and any additional requirements imposed by local building codes. Consult with a qualified electrician or electrical inspector to ensure that your installation meets all applicable regulations. This ensures the safety and legality of your project. The National Electrical Code, or NEC, plays a vital role in electrical safety. It's published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect changes in technology and best practices. The NEC provides comprehensive guidelines for electrical installations, covering everything from wiring methods to overcurrent protection. To stay up to date with the latest requirements, it's crucial to consult the most recent edition of the NEC. The NEC is not a law itself, but it is often adopted by states and municipalities as part of their building codes. When the NEC is adopted into law, it becomes legally binding, and electrical installations must comply with its provisions. It is important to note that local jurisdictions may have additional requirements or amendments to the NEC, so it's always best to check with your local building department to determine the specific codes in effect in your area. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Understanding the structure of the NEC can help you quickly locate the information you need. Chapter 1 covers general requirements such as definitions, wiring methods, and grounding. Chapters 2 through 7 cover specific types of occupancies, equipment, and systems. Chapter 9 contains tables and examples that supplement the requirements in the other chapters. Some key NEC articles relevant to your parking lot lighting project include Article 225, which covers outside branch circuits and feeders, and Article 410, which covers luminaires, lamp holders, and lamps. Article 250 provides requirements for grounding and bonding, which are essential for electrical safety. In addition to the NEC, other industry standards and best practices can help ensure the safety and reliability of your electrical installations. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards for electrical engineering practices, including those related to power systems and grounding. The National Electrical Contractors Association, or NECA, provides guidelines for quality, workmanship, and project management. Consider these as well. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are connected together, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding, including conductor sizing, electrode selection, and bonding methods. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. Bonding methods include bonding jumpers and equipment grounding conductors. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. The NEC specifies the required overcurrent protection for different types of circuits and equipment. The size of the overcurrent protection device must be coordinated with the ampacity of the conductors it protects. Conductors must be sized to safely carry the load current they are expected to carry. The NEC provides tables that specify the ampacity of different types of conductors based on their size, installation type, and installation conditions. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. It's important to select conductors that are adequately sized for the load they will serve. Proper wiring methods are essential for electrical safety and reliability. The NEC specifies different wiring methods for different applications, including conduit, cable, and raceway systems. Each wiring method has its own set of requirements for installation, support, and protection. It's important to select a wiring method that is appropriate for the environment and the type of conductors being used. For outdoor applications, such as parking lot lighting, conduit is often the preferred wiring method due to its durability and resistance to moisture and physical damage. Proper installation techniques are critical for ensuring the safety and reliability of electrical installations. This includes following manufacturer's instructions, using appropriate tools and equipment, and inspecting the work to ensure that it meets all applicable requirements. It's also important to properly terminate conductors, making sure that connections are tight and secure. Loose connections can cause overheating, voltage drop, and even electrical fires. Regular inspection and maintenance of electrical systems can help identify and correct potential problems before they lead to accidents or equipment failures. This includes checking for loose connections, damaged wiring, and corrosion. It's also important to periodically test overcurrent protection devices to ensure that they are functioning properly. Keeping accurate records of electrical installations, including wiring diagrams and equipment specifications, can be invaluable for troubleshooting and maintenance. Consider the importance of safety when working with electricity. Electricity can be dangerous, and it's essential to take precautions to protect yourself and others from electrical hazards. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves and eye protection. If you're not comfortable working with electricity, hire a qualified electrician to do the job. The specific requirements for parking lot lighting may vary depending on the local codes and regulations in your area. It's important to consult with your local building department to determine the specific requirements that apply to your project. They can provide guidance on issues such as lighting levels, pole spacing, and energy efficiency. Energy-efficient lighting technologies, such as light-emitting diodes or LEDs, can significantly reduce energy consumption and operating costs. LED are more efficient than traditional lighting technologies, such as incandescent and high-intensity discharge, or head lamps, and they also have a longer lifespan. Many municipalities offer incentives for installing energy-efficient lighting, which can help offset the upfront cost of LED fixtures. Dark sky lighting is designed to minimize light pollution and glare, reducing the impact on the environment and improving visibility at night. Dark sky lighting fixtures typically have shields or reflectors that direct light downward, preventing it from shining upward or outward. Many municipalities have adopted dark sky ordinances that require the use of dark sky lighting fixtures in outdoor applications. Proper planning and design are essential for a successful parking lot lighting project. This includes considering factors such as the size and shape of the parking lot, the surrounding environment, and the desired lighting levels. It's also important to consider the aesthetics of the lighting fixtures and how they will complement the overall design of the parking lot. The lighting layout should be designed to provide uniform illumination throughout the parking lot, minimizing dark spots and glare. The spacing and height of the poles should be carefully considered to achieve the desired lighting levels. Proper documentation is essential for any electrical project. This includes creating detailed wiring diagrams, equipment specifications, and installation records. Documentation can be invaluable for troubleshooting, maintenance, and future modifications to the electrical system. It's also important to keep records of all inspections and permits. By following these guidelines and consulting with qualified professionals, you can ensure that your parking lot lighting project is safe, compliant, and energy efficient.